Okay, so hello all two of you who will ever see this video. Today we're going to be making a case for an iPod, and I just want to go over some of the cases we have here, as well as the iPod we'll be using. So here it is. It's a iPod 3rd Gen. It's a thin one, 15 gigs. There are two thicknesses of almost all of the iPod Classics. And we have a selection of cases here. So this is the actual iPod case. Now we have two cases here which are actually the same. So this is for an iPhone 3G, and then this iPod 1. These are the same style of case in the sense that they use the same retention mechanism. So we can actually see that it slips into the bottom there, and there's a little indent here which is used to assist when placing it inside the case. We have this iPhone 3G one, which is the same idea, except we don't have the cutouts on the 3rd gen case, but these are the same type of case. We also have this one, which is actually not the same type of case. If we removed the front, this would not hold an iPod. So that is a completely different design. We also have these two types of cases, which are the same. So that's another 3G case. And then this one for a radio, it just slips out. And then we have these two types of cases. Now these are what I just call bins, essentially. These are bins. The iFixit one, it's got a lip around the edge which interfaces with the top case, and then it's held in place with magnets. We have this as you can see, we have a lip which interfaces with the rest of the case. So these are the same types of cases. We also have these two, which are again the same. Oh, there's a hair stuck in there. So this one opens up like a book, and it's got a little clasp to shut it. We have this calculator, again same kind of case, but there's no clasp. So there's plenty of options when it comes to all of these different types of cases. And then last one is just a bin with a latch and a hinge. This is the most complex type, and there's many options for making that hinge. I can't shut it again. So we have quite a few cases there which we can use, and we actually have a variety of materials that we can use to optimize a case for. So this 3rd gen style case here is it would be possible to make this out of, say, PLA, which is very good because today we're going to be making something that is 3D printed. So step one of this is to create an accurate model of the original device. Because there are Apple guidelines out there, you can actually get these for free on some archives, and that is a very good option. But we're going to be reverse engineering this and taking dimensions from the actual device. Now, the first ones I want to do are get the width. Now we take several measurements of the width to see if it's consistent. Of the height, again, several measurements. We also want to take the depth of the buttons. Now, if they're indented, what you can do is hold the base of your calipers down and just pull down. It's about 1/2 millimeter. So 1/2 millimeter of depth. Do the same for the wheel. Again, just hold it in the middle, make sure it's flat. 1/2 millimeter. We can also take the dimensions of the port, because this is very, very important that we don't obstruct this. Make sure you have a consistent, there we go, actually going to screw this up. Can't tell which way I screwed it. Screwed it the wrong way. 21.5 millimeters. Also take the width, not the width, the length of the port, 2.5, and then what we can use is a fillet gauge to gauge the fillets. That was very self-explanatory, wasn't it? We're going to want to take a fillet of all of the corners, and then we're going to punch them in. Okay, so I lost my fillet gauge, and I've printed a new one now. Let's just look at it for one sec, right? Look at those layer lines. You're not going to be able to see them. Basically, this is the best print I have ever done. You're not going to be able to see it. Best print I've ever done, hands down. And it's because I accidentally used the Ender V2 profile on an Ender V3 SE. It's probably down to the speed that I was printing at, but I was under the assumption that it would completely chew through my print bed. Anyway, we now have a fillet gauge. So all you do to use this now, this reads in radius. So keep that in mind. On Fusion, fillets are radiuses, or radii, I don't know. No, radii is a different measurement. Anyway, on an iPod, all you do is you hold it up to the side, completely perpendicular. Don't cover the mic, completely perpendicular. Now, on some curves, so if we look at the one, as you can see, that's a complete 45-degree angle, isn't it? So that would be very, very hard to use, especially in a situation like this where I can't actually measure, say, the fillet of the buttons. It's just too big. So what you might end up needing to do, so here's the button, the hold switch. What you might need to do is actually hold it in front and see how much light gets through. Now, keep in mind, there are flat sides to some of these, up to about 3, there are flat sides. It's only the curve on the inside of the fillet that is a radius. So don't measure from the flat sides if you're measuring small fillets. What you do, if you have no other option, is generally you want to just hold it against it. It will lock into place and you'll see perfectly. But if you can't do that, you hold it in front and you see how much light gets through. And you want to align the light so that it's even all the way around. You'll get a knack for it. It took me a while to learn how to use these properly. Anyway, we now have the fillets, so we can finally begin modeling this. I've also got my coffee, don't knock that over. So yeah, sorry, that took a while to get through, but we just make a rectangle. We're going to measure the width, so we're going to take several measurements. We've already done this in the last segment, but I've already forgotten. About 62, more like 61 point something. Okay, so it's even on the two sides. How about the middle? Okay, so that's 61.5. So I'm actually going to take the measurement from closer to the edge. 61.7. Now, when we're making a case, we want this as accurate to the model itself. So 61.7 by, and the reason we want it to accurate to the real model itself is because we can modify the sketch to fit our needs. We can add offsets, we can do all that jazz. Okay, gonna take one from the left. Make sure we are perfectly aligned. So that looks like 103.5. Push it all the way to the back. 103.5. Let's go from the middle. The middle's not as accurate as this. Yeah, so we're going to do a wider section. 103.3. Okay, so we've got most of the model now. Here's an issue when it comes to 3D modeling. Do I use fillets on the sketch or do I use it on the model? Generally, if you're replicating a model that you can simplify into a flat plane, you'd want to use a fillet. But if you are making, say, a box, then you want the box to be as accurate as possible, so you'd use the fillets on the box itself. I don't mean accuracy there, I said the wrong word. If it's a design choice, you use a fillet on the model. If it's a constraint, so we have to use the fillets here, we'd use it on the sketch. That's the way I think of it. It doesn't particularly matter too much. The good thing about doing it in Sketch is it's much quicker than doing it in a model. Also, if we were doing it on the model, we would have to extrude it before we can add a fillet. So this is more for the mathematical side of things. It's kind of hard to explain. You get a feel for it. So now we have that. We can also begin adding the what's it called? The button. So now we're just adding the measurements, which we can say absolutely. So it looks like it's actually 2 millimeters. Now these calipers, the top surface along here is a measurement surface. So all you do, instead of using the bottom, is you hold it against what you're doing and you just push. 0.3. So now what we're going to do is we're going to add whatever width, 0.3. Sorry, whatever height. $10.5, and then the gap. $1.6. So that was what, 10.5 plus 1.6. So 10.5 plus 1.6. I'm really bad at maths, but that just made me look very smart. Now how's the best way we're going to measure this? And also here's the deal. So if you have a switch, you need to account for where the switch might be. It could be in any position between that 12.1 parameter. The way I think I'm going to do this is by adjusting from the right side using the flat gauge. Yeah, why not? There are better ways to do this. Make sure it's perfectly parallel. 8. So we're going to measure from here to here. 8. Okay, so this dimension tool, absolutely invaluable. Try to avoid using it when you're using rectangles. So what you can do is you can make a random size rectangle right there. I didn't even check what size it is. Oh no, what do I do? We're going to go back to the sketch. I want to edit the sketch. What am I selecting? I'm doing something wrong here. Is it configure? No, it's not configure. See, it's locked. Forgive me, I forgot I was already in the sketch. Okay, right. Anyway, so we have a random thing and we can dimension it up. Now, the reason I don't want to do this, if we just set it to 1, is because this is just more steps. Anyway. Okay, so now we have roughly a working model. We could build a case for this. But I want to add an indent for the screen. And I'm not sure if I'm going to bother with the buttons, but we might do it anyway. So here's an issue. There is nothing we can measure properly when it comes to the screen. We're going to be doing it purely off of what we can see. Now, generally you wouldn't do this because you're not using an iPod, I hope. If we get it lined up, let's just say 41. This doesn't have to be terribly accurate. So 41 by 34. That's about right. Now I need to precision it. It's not the best way to do that. This is not best practice when it comes to measuring things, I must warn anyone who wants to even try. But that looks like a perfect 6mm. So what I just did there is I measured it by holding the back plate. Now this is not a measurement surface, so it's technically not accurate, but it works as a perfect little place that I can rest my calipers. And you can see there. And then I just used that to hold it perfectly flat, and I measured the light going from the top jaw. Don't do that, it's bad practice, but if it's your only option, then reverse engineering is basically just doing whatever the hell you can. I did say 6mm, right? Yeah, 6mm. Okay, and then we're going to take a measurement from the left side because I don't want to clutter my dimensions. I'm going to do the same thing again. Again, this is bad practice. Avoid doing this if you have any better options. Perfect 10mm. So now if I do 10, we're going to create a driven sketch, 10.7. So actually, so look, if I edited this would not change a thing. We can't edit that. So we're going to do 10 plus 0.7 divided by 2. There we go. So that is now perfectly centered. We have an iPod screen. When it comes to the buttons, I don't think I'm actually going to model these because that's not the objective of this video. But these are 11mm diameter circles for the buttons and 38.7mm wheel with a 14.3mm center button. Okay, right. I'm not going to bother with that because honestly, scratching this up is not an issue. If we wanted to completely avoid scratching the entire faceplate, we wouldn't have modeled the entire screen. We would just model the edges and maybe make little cutouts for the circles on the outside, but we'd just make it support on the outside. But if you think about it, that would cause more pressure to be exerted on the edges, and that would cause more scuffs. Okay. So we now have an accurate model. Now I'm going to do both. We're going to do 0.7 mil in that direction. Now, we're going the wrong direction. We're actually going through the build plate. Not the build plate, or through the surface. Did I? Yeah, I did. Now, we're going to take this one, minus 0.3. Okay, now we have a cutout. I'm actually going to edit this. I'm going to do it. I'm going to keep 0.7 because 0.7 is a good number. But we're going to do negative 0.5. Now, what you would want to do is, if you're using something with actual buttons, so say the switch, you'd want to find the length, 0.3 mil, and we'd want to basically give it some clearance. So we want to make sure it can move freely, so we can put it in the case without toggling the switch, and give it maybe 0.5 mil or even up to 1 millimeter if it's like a what do you call it, a membrane style switch. Just do a feel for it, make sure there's enough clearance, and account for 3D printer clearance. Someone else's printer isn't going to be as accurate as your one, so just account for stuff like that. We now have an accurate model, and we also have the switch up here. We're not going to extrude the switch. Now what we can do is add an offset for the wall. Now I want the wall to be 1 millimeter thick. You could make it 2 millimeters. I find 1 millimeter to be very, very strong because we can account for what do you call it? We can account for like wall thickness and that kind of stuff. We're going to go back to these two sketches and just add them to it. Double click, and then you just select the sketch. If your sketch isn't visible, make sure it's visible. Okay. We're going to delete this original one. That was to make a point. And now we can rename this. We're not going to bother actually. So now we have the wall. Now, as you can see, it's not extruded here. Okay, so now we have this entire thing. Now this is kind of here just as a placeholder to make sure that we don't screw up. In fact, you know what? We should probably add an offset. Let's do 0.2. So now that's going to be a 0.8 millimeter wall on that side. You'd want to strengthen it up a bit more than that, but it doesn't particularly matter. Okay, that's gone fine. And now we can extrude this wall. So if we actually remove the body here, so we can access, there we go. We can now set it to join, so this will now be a single model. We want to find the thickness. Sixteen. Almost 17, 16.6. The middle of iPods is always thicker. 16. So let's actually do just 16 because we're going to use the corners as the retention. So minus 16. Now, minus 16. 1 second. Alright, I'm back. Right. This is a very dirty video. Right. So what we came to, what was it? I've already forgotten. God damn it. It was 16 mil. 16 mil. So what we could do is do minus 16.5 to account for the inside thickness that I've added with the two-sided sketch, two-sided extrusion. But I'm not going to do that. What I'm going to do is do minus 16.5, no, 16.5, and I'm going to create a new body, and then this is the iPod. Now we're going to add a fillet of, what was it, 5 mil. Always double check. 0.5 mil. So now we have these lines here. Now these are what we're going to use to create the retention mechanism. So this is why having a positive model is so important. So now we have the sides and we can extrude. Remove body 1. You should name these bodies. Going to join. And we're going to join 2. Okay, we're actually not going to do that. We're going to do a project. Best way to do this. Right. What if we do an inspect? That's diagonally. Right. Tell you what, we're going to let's pull this in a bit. I'm going to remove body 1. And now what we can do, remove body 1, pull this up, include again. We can join. Can do extent type to object to this face. Can we move that? There we go. So now we have the height that we need. As you can see, it comes up to the edges. Now this only goes to the extent of the wall, but this is now perfect when it comes to it. So what we could also do is set up a, what's the best way to do this as well? Yeah, okay, let's do it here. We're going to include, create, could actually include 3D geometry as well. This is the way I'm going to do it. Now, if we finish this sketch, oh, we're already in the sketch. Oh, no, we're not. Okay, so we're still in here. Yeah. We're going to add lines to the corners. Do 2.5 mil. So what I want to do is I want to revolve around this corner. Yeah, that's how we're going to do it. So we're going to do 0.5 mil. I guess what I could do is create a sketch on the side. There's many ways to do this. Fuck me, what's going on there? Oh, that's the top corner. We don't need to worry about that. Yeah, I'm kind of lost at the minute. Don't worry about it. We're going to include this point. Now we're just going to draw a line. There we go. We're going to come up here and we're going to, let's say, make a box. Now we can fillet it. Oh, we can just make it 5 mil, can't we? Can we? No, I know what we've done. 1 mil. It is 1 mil, if I remember correctly. You can just drag to add constraints. There we go. Fill it. Let's do 5.5. It's a very dirty way of doing it. We should be able to do a revolve. There we go. Angle, let's do 90. Gone the wrong way. Okay, minus 90. And then we can join it, but we've actually done this wrong. So if we include this geometry, now that should be separate. It's a sweep. Sweep will actually work here, but we want to do a revolve. Axis, what was it, minus 90? I'm learning myself. So what we've done here as well is we've done a join, and it's joined the two bodies together. We want to ensure that it is not creating. So we're actually going to name this. We're just going to call this dimension, and then case. Dimension, no, base dimension, wall thickness, and then corner. Name it whatever you want. Minus 90. And we want to make sure that dimension is not visible. So now we have a corner. Now this will be enough to hold the iPod together, but what I'd actually like to do is do a fillet. Let's do, 10's a bit extreme, isn't it? Five would work. And then we're going to add a fillet on the outside edge. 0.5 works. So now we have the corner post set. Now this will lock the iPod in place. We could do this on all the corners, but that is a very dirty way of doing it. What I'm also going to do is set up a clip system on the side. So if we include dimension again, as you can see, now, where the hell is that case gone? If we compare this to the original case, now this case is perfect. They will have used this using the actual Apple guidelines. They only have corner posts, but this is using very flexible material. You know, it's not exactly silicone, but it's quite flexible. If we compare that to PLA, we're not flexing this. So you need to consider the mechanical properties of what you're going to be making this in as well. I would not want to make this out of a very flexible material because the iPod would fall right out. And also, this is a dirty way of doing it. I have done possibly the hardest way to do this. I like this method, I've done this before, and you've probably seen me struggling there because I've not done it in a while. I don't particularly like cases of this style. What I would prefer to do, instead of this very complex geometry, is to just have it on the sides. They don't look as nice, but they'll hold it equally well. So we're also going to make one on the left side. So we already have corner thickness. Okay. We're also going to add another sketch on this plane. Now, it's not bad practice. Think of your sketches like features. Now, if features are dependent on other things on the same plane, then you'd want to include it in one sketch so that you can make it, say, constrained to the midpoint. So that if I changed the width of this model, the midpoint would change and it would do it all for you. That is parametric constraints. We don't need to do that, so we're adding a new what do you call it? A new sketch. Right. So we're again going to include this entire geometry. There we go. We're going to add a center point rectangle. Oh, we're not. Just a regular rectangle, I suppose. So as you can see, we are constrained there, so it's now 1 millimeter. We're going to set the midpoint of this to the midpoint of this. Now we have one in the middle. We're also going to set the dimension to that to that. There we go. We're going to set the width. $25. Now the reason I've done this instead of typing it first is because we've just done a parametric constraint. If we set it to 25, it is still going to be perfectly in the middle. If we, say, measured from the sides and just did all the maths ourselves, changing this, we'd have to adjust everything. I'm quite out of practice, as you can probably tell. Now, what we're going to do is just do the same thing. I guess we're going to do 0.5. This is just so we can get a sketch going. So we're going to set a sketch on this side. Now we're going to do something a bit different here. So we're going to include this geometry. Yes. We're going to go up 1 mil. Yeah. Now, how can we do this in a way that would work? We could do a 1 millimeter thing. Now, this is the best way to, what's it called? To create good curves. Now, the way I did it in the previous one is not ideal because we set a fillet and we could calculate what the perfect fillet size is by doing some maths, pi and all that, or we could set an offset. As you can see, we've got the geometry right here. Now what we're going to do, we're going to extrude this and we're going to do to object. Now, if we did it just to length, then if we changed the width of this clasp, it would not be happy. Now, what did we set the, just do, what was it, 5? That doesn't look right, does it? I don't like that. We do it to the corner, 5. Do it to this corner. That'll also be 5. I actually quite like that. But what if we set it further? Okay, we're going to do that, but we're going to modify this sketch. So somewhere down the line, let's do... What is it on that side? How far does it come up? It comes up quite far. Let's actually go down about halfway. So we're going to find the midpoint of this arc. Going to do perpendicular. It is 135 degrees, but we can set it to perpendicular. This perpendicular... We actually can't do that, can we? I'm so out of practice. I should have done a bit more research before I started doing this video. Let's not extrude that. Boom. Right. Two. Yeah, two. Let's get the other side. That corner and that corner. Two. I don't like two. Three. Four. Nah, three. Three works. And then we're going to do a 1mm. We can't do a 1mm. Oh, it's on the inside I did it, isn't it? How do we feel about that? Is that consistent? Let's do a 0.5 on both sides. It says we're doing 10 edges. Right, so let's just select two. Oh no, I did do it correctly. Do 0.5. 0.5 works. But we do have this ugly seam down here, so we're also going to include the edges down here. That's why. Where have we gone wrong? Gonna join. There we go. Right, so that's where I've screwed up. So we do have this lip here, so we could actually fix that by doing the dimension. I'm not going to bother. There are ways to get rid of it. In fact, I wonder if we can just get rid of it here. Can we delete that? No. This is so dirty. I don't design cases. Right. We've already done that actually, so we're going to set the fillet again. You. Let's do you as well. 0.5. Will that work? If you hold control, it will actually include. So if we do that, it won't actually work. Let's just do you first. In fact, you know what we can do? That's how we're going to get rid of it. We do need to get rid of it. It's stupid for me to ignore it. There we go. Now it's perfect. This is what happens when you try and cut corners. 0.5. How do we feel about that? I like that. Right. Tell you what then, because I'm actually quite liking this. This was just going to be a dirty video. So we're going to call this side clip. Side clip. What are we calling this? Oh, side clip surface. Yeah, sure. I'm liking this quite a bit. For a quick and dirty video, this has gone quite well. Right. So now we have an issue up here. Now this is what happens when you do a fillet that is a corner chamfer. So where have we gone wrong? Okay, right, actually here's something as well. If we do a setback fillet, you can see these are different. If we look at an iPod, you can see it's got very sharp corners even beyond the fillet. If we did a setback, it would not have these sharp corners. It's quite easy to tell the difference, but it is important that you know the difference. The best way to tell, especially on a shiny surface, is to look at the corners. Are they the same radius as the fillet, or are they the same radius as the geometry they're going on? Not the same radius. The same center point as the corner they're going on. This, we can tell it's on the same center point of, Jesus Christ, the same point of the corner they're going on, the same center point, because it's got a very sharp corner. I'm doing a very poor job of explaining this. I don't record videos like this often. Anywho, I've done a lot of mistakes on this already. Can we just cheese this? We can't cheese it, so we do have to fix it. Tell you what, we are going to cheese it. Right. I'm going to do another sketch because this is a unique feature. Yeah, so we actually do have the geometry we need. We're going to include this geometry. We're going to set the corners. Now we can extrude up. This just gives us a surface that we can work with. Let's do 0.5. We're going to set you up here. Now, it's important. He says, it's important that we actually make this accurate to the original one. So I'm going to try and do this. One. Offset this by 1. So now we have that accurately modeled. We're going to get rid of this, but we do have a center point now. So what we can do is we can do this revolve. We can revolve that around this axis. It's already done 90 degrees for us. We're going to join. You know what we've done? We're going to do a revolve, as you probably figured out. We're going to join axis, this axis, because it's the center point. Okay, now we have a perfect thing. Now, to name your sketches. Also going to revolve that. Dinner, it's perfect. Okay. So that little extrusion we did, the 0.5mm extrusion, that was just a, what do you call it? It's not a dimension. I forgot what I called now. If we go back in here, construction, that's what it's called. Jesus. Right. So now we have this. We can set this to, what did we do? Was it 5mm? Was 5mm. Not 56, 5mm. And 0.5. We do the inside? We did not. This should now be a case. Now, before we finish up, we're going to fillet everything. Did we add an offset here, actually? So face dimension, we did not. So we're going to add an offset to this. -1mm. Going to not include that. Now, order of fillets. So actually, let's demonstrate this. So we're going to do, what was it, 0.5. Now I want to fillet the corner, and it's going to be quite hard to do that. Now we could do it this way, and it will work, but it looks a bit funky. So let's do it a different way. Let's do the corners that could potentially disappear. It doesn't necessarily matter on this geometry much. Let's do 1mm, and then we can do one fillet around the outside, and it will be 1mm. Boom. Now we have a perfect thing. We're also going to do this. Let's do 1mm. Yeah, why not? And we're going to do a fillet along the edges. Of 0.5 maybe? No, 0.2. Now this is more for the sake of printing. We're also going to add a fillet to the outside. Now this is what I meant by design choices. So we're not actually going to do two, we're going to do two. We're going to do one. This is what I meant with fillets. Is it a design choice or is it a functional choice? When we created the model of the iPod, that was a... did I say functional choice? If we didn't include that fillet, this model would not work. That's basically what I mean. Now we're finishing up this case. It is a design choice. I'm doing a really poor job of explaining this, please forgive me. This kind of stuff kind of comes from kind of just trial and error. Do we have a lip here? We do not, so we've actually done that corner perfectly somehow. But this is now ready to be printed. Now, I've tried to consider some strength challenges when it comes to PLA, so this point here is now a weak point. Because if we think, the way this is going to be printed, it's going to be printed like that. So the layer lines, they're going to be the weak point. We can combat this by printing at a higher temperature. I'm actually going to print this at 225, which is higher than most PLAs. But we'll see how it goes. I'm going to print this now, and I'll come back with the model. Okay, now we're at the printer, and as you can see, we have fingerprints on the build plate. So we want to get a rag and some isopropyl alcohol and just scrub it down. Any fingerprints left on this build plate will transfer to the first layer of your model. It can cause build plate adhesion problems, and you will see actual fingerprints on the model itself. Fingerprints are pretty much inevitable, and if you have a textured build plate like this, I advise using against scrapers, even plastic ones. As you can see, the build plate is actually in perfect condition, except for here. Can we clean that up a bit? Not perfect, there is some damage going on there. But now we've got it cleaned up. There's a little bit of something there. Can we clean that up at all? Good enough. Okay, insert that. iPod case test. Confirm. And now it's going to heat up, and I'll be back with a model. And here we are. So the build plate is still warm, but we have an iPod here. As we can see, the corners fit in fine. And it just slips into place. I'm going to pull it off the build plate. I have to flex it a bit. There we go. That's why you need good bed leveling, so you can do stuff like that. And as we can see, it's held into place. Look at that. So I didn't do a single test print. That all came from just standard modelling practice, I suppose. Does wobble a bit because we've scaled it, but it should just pop right out. There we go. Look at that. So that's right off the build plate, some string in here and there, but look at that. Came out very nice. So this is printed at 220, so these should be fairly strong. There is a bit more flexure than I'd like, but I'd say that just helps it stay in place. Yeah, so it does slide in quite easily, so it will fall right out. That's a result of me not adding offsets. But overall, I'd say that's pretty good. We didn't include a hole for the charge port, and as you can see, it covers the screen, but I'd say that was fairly successful. See the overhangs there? Come on, focus. Zoom in. They printed very well. How about the wall? This is the one I was concerned about, but no, that's printed perfectly. So there we go.